Let's do 4 HSPT questions. A number of you are taking this test soon, tomorrow. Some of you are taking it in a couple weeks. But regardless, these problems that we do today should apply to you. You should understand the basic concepts, and hopefully it will help you when you sit down on your HSPT and you are looking at some question. You say, aha, I remember that from the lesson that Mr. Lipscomb taught us. So let's get to work. We're going to do 4 sample problems. Here's the one that I promised you from today. It is a problem that asks you how far it is on the coordinate plane between point A and point B, giving this plane as described right here. Now, the key thing to do is to, let's draw ourselves, when we solve this, I'm just going to draw a coordinate. How can we draw a coordinate plane? Let's draw a coordinate plane. And I'm just going to draw it, whoops. We're going to draw quadrant 1, right? So this is where y is positive and x is positive. And so we're going to look at, 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm going to draw this. Over here, they don't draw the grid, but we kind of have to draw the grid to understand what's going on. 1, 2, 3, 4, 5, or maybe you see it, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here's our coordinate plane. Now, if you know how to do this problem, go ahead and solve it and just fast forward through this explanation. You don't have to sit here and watch me do it if you know how to do it. But I'm going to mark these 2 points, 6, 7. I'm going to do the whole problem for you. 6, 7 and 12, 15, 12, 15. Okay, so yeah, let me maybe make these in a different color. Let me make them big. 12, 15, and 6, 7. And you want to know what the distance is between these 2 points. So to do that, we have a, let's see here. How can we do? Can we do, yeah, we can actually do a line. Let's do, whoops. So we have our line here, and that's the distance that we're looking to close. Now, this is a diagonal across, I don't know how far that is. You can't just take, 6 plus, our x coordinates, which is 6, and our y coordinates, which is 8. I don't know how to figure this out, but we can do this. Watch what we can do. We can make a right triangle out of those points, and this is the way that you find the distance between points on coordinate plane using the Pythagorean theorem. You always use the Pythagorean theorem. So let's figure out how long this side is. Well, if my x coordinate goes from 6 to 12, I know this distance, 1, 2, 3, 4, 5, 6. This is the side of 6, and this side is 1, 2, 3, 4, 5, 6, 7. This side is 8. Now I can use my Pythagorean theorem. I'll just call this side A, and this side B, and so this is side C. So we'll write our formula. We'll write it in green. And so we'll say, well, we know that a squared plus b squared is equal to c squared. And c squared is my distance from here to here, which is the distance between the points, right? The distance between point A and point B. Right? This is point A, and this is point B. So if a squared is 6 squared plus 8 squared. That doesn't equal 14 squared. Be careful. You don't just add these together. You have to do all the math here, and that's going to equal c squared. Well, that's 36 plus 64 equals c squared. And 64 and 36 is 100. Oh, this is going to work out nicely. So let's write it like this. Let's write 100 equals c squared. So then our c is equal to 10. So our distance from here to here is 10. And so the correct answer is C. Okay, let's look at problem number 2. Problem number 2, let's get ourselves, oh, wait a minute. We are done with this problem. Happy cat. Okay, now let's get our new screen, and let's go, we're gonna paste our problem in, and we're gonna say, okay, well, we have some more geometry. So we wanna figure out if this side is 6, how far is this long side? Well, it looks like we don't have enough information, but actually we do. If we know that this is a 45-degree angle here, let's make that a nice dark blue. We know that this side, because it's a right angle, is 90. And we know that all these angles together have to equal 180. So if we take, because it's a triangle, so 180 minus 90 is 90. 90 minus 45 means this side has to be 45. And that's a standard right triangle. If you ever see a triangle with a right triangle, a right triangle with a side of an angle of 45, you know the other one's 45, because 45 and 45 is 90. And then the last side is 90. So there's our 180 degrees. So the other interesting thing is that if this angle is 45 and this one's 45, you know that you have an isosceles triangle. You know that the two short sides, or the two sides that are opposite these 45-degree angles, must be the same length. So this side, if this side is 6, then this side must be 6, because this is a 45 and this is a 45. So if this side opposite is a 6, then this side opposite, this one is a 6. And if you think about it, this will make sense in a triangle, that if any two sides opposite, I mean, it would work also in a triangle where you had, you know, if this side was 50 and this side was 50 and this side was 80, then these two sides would have to be the same length. So if this was 11, this would have to be 11. So just know that about all triangles. If you have an isosceles triangle where two angles are the same, you also have two sides that are the same. That might sneak up on you somewhere else in the HSPT. So let's look at this. We have now a right triangle, and we know that two sides. So this is side A, this is side B, and this is side C. Well, we'll leave it as X because they call it X. So we know that A squared plus B squared is equal to X squared. So 6 squared plus 6 squared is equal to X squared. 36 plus 36 equals X squared. So 72 equals X squared. Are we done? Say, are we done? And the answer actually is yes. And the reason is because they asked the question, what is X squared? They don't want to know what X is. They want to know what X squared is. Well, we know what X squared is because we just figured it out. So our answer here is C. And when we get a correct answer, we go, happy cat. All right. So there are a couple key concepts here. I love this concept that on a triangle with two angles that are the same, the two opposite sides are the same. That'll come up somewhere on this HSPT. So remember that. And then you use your Pythagorean theorem to solve from there. All right, let's go new problem. And we're going to solve, okay, we have got a new problem, and it is the series problem. So I'm just going to rewrite this series here. 24, 9, 21, 9, 18, 9, 15, and they want to know what the next two numbers are. Well, I want you to remember back to an earlier lecture, or an earlier lesson I did. You can find it in the video section of Schoology if you're a St. Simon student. If you're not a St. Simon student, then you'll have to just bear with me for a second and understand that there are some concepts that our students have learned that you may not have learned. But we'd like to, whenever we see a series, we like to look for patterns. So we're going to say, well, this is minus, and so we find the difference between each set of numbers. So we go minus 15, and then we go plus 12, and then we go minus 12, and then we go plus 9, and then we go minus. This is weird. I don't see a really good consistent pattern here. So usually what I say, and it's not a divide by, it's like you get big, small, big, small. So what I like to do when I see a problem like this is I like to look for double skip what I call a double skip pattern. And so I look for a pattern between all of every other one. And let's see if we can find a pattern between every other one and see what happens. And this might make it obvious. So we look for this pattern. This is why I call it a double skip pattern. And now you should see, hey, this looks pretty easy. Because here I have minus 3. Let's do this in a different color. We go minus 3, between the circles, look, 24 to 21 minus 3, 21 to 18 minus 3, 18 to 15 minus 3, and here we go minus 3. So this one should be 12. And let's look at our boxes. And our boxes go, 0, 0, 0. We go 9, 9, 9. So this one should be 9. So I say that our answer should be 9 and 12. And then, in fact, we have that answer, 9 and 12. Notice, again, we look for normal patterns, but if we don't see normal patterns, we look for patterns between every other one, and then on the, every odd one, and then between every even one. And that just totally nailed this problem, made it totally simple. Okay, and when we get our question answered correctly, we go, uh-oh. Dang it, we lost our, what? We lost our images. What? What? I'm beside myself. I've lost my happy cat. Wait a minute. Oh, goodness gracious. Oh my gosh. This is killing me. No happy cat. All right, happy cat. Oh, there's my happy cat. I'm not sure where she came from. Can't see the picture over here, but we got our happy cat, and we can now move along. Okay, create. We're going to do our fourth problem is also a series problem. Okay, so we're going to review this series, and this is an interesting one too. 4, 8, 9, 27. This one is going to be a little bit, maybe a little tricky, but we'll see. So we got, kind of +4, +1, +18. Wait, this is crazy. I'm going to go double skip pattern, and I'm just going to look at, I'm going to try these guys. And it wants to know what the next two numbers are. Well, let's look. What do we know is true about every box here? Interesting. This looks to me a little bit like, 2 squared, 3 squared, 4 squared. This one must be 5 squared. So I'm going to put a 25 in here. And these circles are interesting, and you're going to have to kind of, I don't know if you see this or not, but this is kind of 2 cubed, 3 cubed, and 4 cubed. So this one over here should be 5 cubed. And 5 cubed is 5 times 5 times 5. So 25 times 5 is 125. So this one here should be 125. So I think our answer is 25 and 125. And in fact, we have that answer over here. So our answer is D, and we're going to go happy cat on that one. This is one where I don't really know how to explain it any better, but the double skip pattern kind of opens up your eyes, and you should probably see the squared pattern and then this circle pattern. Okay, well, we'll leave it at that. And we'll go, we're going to go back to, whoops. We'll come back to square one. And, you know, I promised you I'd do those problems for you. Hopefully they were helpful. And we're out of here. All right. Good luck on the HSPT tomorrow or whenever you're taking it. Bye-bye.